Next, we've got Ofer Baharav from Real VR. He's going to talk about Villa, making 3D VR map navigation intuitive and productive.
Thank
Over to you.
Thanks. So, hello, my name is Ofer Baharav. I'm founder and CEO of Real VR, which is producer of Villa. I'm going to be a bit robotic because I just made my way from Israel over here, so I didn't have as much time in my itinerary as planned previously. I found myself in a war zone. But I'm here, I'm safe, everything's good, and I'll be reading from the notes. So, Villa is an AI-driven immersive platform for 3D world travel and creation VR. We're live on MetaQuest with nearly 1 million all-time users. The travel experience is built in Cesium for Unreal, enabling real-time global navigation, multiplayer, and AI assistance. And today I'll be showing you how we optimize Cesium for performance in mobile VR, enabling photorealistic multiplayer at planetary scale. One of our first major bottlenecks was shader complexity. Cesium's default shader was built for generality, shadows, normal maps, opacity blending, all great for desktop, but too expensive for mobile VR. We stripped it down and rebuilt only what we needed, removed shadows in normal maps, removed opacity when flying low, where tile density is high, but kept dynamic shader switching for effects like depth handling and skirt blending at higher altitudes. Then we tackled visual fidelity. Cesium's MIP biasing produced blurry terrain on Android. So we added manual MIP bias control to smooth aliasing. We built a custom texture filter, sampling the texture at 4 offsets and averaging them. And finally, the screen resolution dependency. Cesium native uses compute SSC function that relies on the device's screen resolution to determine screen space error. The problem on Android, there's high screen resolution. It means that there's more detail requested, and we were blowing our performance budget. So we rewrote the compute SSC function to remove the screen resolution dependency entirely. Instead, we now control pixel density dynamically and adaptively based on a target frame rate of 120 FPS, scaling to GPU-CPU capabilities across Quest 2, 3, and Pro. This gave us tight control over performance versus quality, was key to hitting smooth multiplayer at global scale. Cesium and Unreal doesn't scale naturally when users move far from origin. The world starts to break. So our fix was to keep each player at origin using Cesium's origin shift and global anchor. Instead of Unreal coordinates, we sync players in ECEF, the Earth-centered, Earth-fixed space. This means the Earth rotates below each player, but their real geolocation is maintained. Players can fly past each other across the globe and see each other in accurate relative position. It's a multiplayer system that works at planetary scale and feels seamless in VR. With GPU resources maxed out on Quest, we turn to Snow Occlusion, a UE4 CPU culling adaptation released by Fast Travel Games. It brings back the CPU-based culling system that was deprecated in UE5. We customize it to run dynamically in real time, enabling tile culling on the CPU instead of the GPU, which is usually what happens, where users are stationary in high-density areas. This saves us between 50 to 100 draw calls in city environments, and is key to maintaining stable performance in VR. Originally, we had around 400 draw calls, and now we're down to 300. Major credit to the Fast Travel Games team for making that adaptation available. It gave us a critical head start. So we've optimized for a target frame rate of 120 FPS using application Space Warp, even on mobile Android class hardware like Quest 2, 3, and Pro. By dynamically adjusting pixel density based on device performance, we're getting closer to photorealism at scale, with 60 FPS during multiplayer flight and smooth visual fidelity across the globe. When it's not multiplayer, by the way, it's about 120. So what you're seeing, well, I'm not able to show that video, again, due to this itinerary change, but I had a video for you showing New York City multiplayer fly-through, enhanced with AI navigation. And next, we're expanding into defense, enterprise training, and live operational support. So the second clip I was going to show you, by the way, these are all on our YouTube channel, so, but is for mission rehearsal, terrain familiarization, and combat support, all in VR. So Villa already handles globe scale multiplayer with high fidelity and low compute cost. If you're working in defense simulation or training or building for those use cases, let's connect. We're actively forming partnerships and looking for deployment collaborators. Thank you.